Theories of growth. The three theories or models that we will look at here are, number one, the classical model, the neoclassical model, and the endogenous growth model. The classical model, that was originally developed by Thomas Malthus and hence also called the Malthusian theory, essentially says that the growth in real GDP per person is temporary, and when this growth level rises above some subsistence level, either due to more capital or better technology, then this increased wealth per person causes a population explosion, which essentially brings the growth per person back to the subsistence level. So essentially, if an economy becomes richer on a per person basis, population goes up. The way you can think of this is GDP or income per person. If the number of if the output goes up, then the population will also go up. So overall, the GDP per person will stay the same. Now, the prediction of the classical model has clearly turned out to be not true. We have noticed that the growth per capita income has increased, and according to this model, the population should have also increased. But what we have noticed over the last several decades is that the growth in per capita income has happened along with a slowdown in population growth. So clearly, the prediction by this theory has not turned out to be true. Hence, this is not taken too seriously. The next theory, which is where we will spend most of our time, is the neoclassical model. Now, in very simplistic terms, according to the neoclassical model, the long run per capita growth depends on exogenous technological progress. Exogenous means that technological progress is outside the model. So even though it is a key factor that explains growth, the changes in technology are not fundamentally part of the model. And finally, we have the endogenous growth model, which tries to explain how technology actually enables growth. So we'll spend a fair amount of time on this and some time on the endogenous model. The neoclassical model, this was first developed by Robert Solow in the mid-50s, and hence you will often see the reference to Solow when this model is being discussed. The objective of the neoclassical model is essentially to determine the relationship between long-term growth rate and, number one, savings and investment rates, 2, rate of technological change, and 3, population growth. So this is the objective, and I will again repeat the core point that was made on the previous slide, which is that according to this model, the long run per capita growth depends on exogenous technological progress. Now, a word of caution on this section. The curriculum spends a lot of time deriving equations and giving explanations, but I honestly feel that it's not worth spending too much time understanding the derivations and the explanations. So what I have done here is just given you the core relationships that you need to memorize. So here is core relationship number 1. The growth rate of output on a per capita basis is theta divided by 1 minus alpha. The theta represents the growth rate in total factor productivity. So this is the A, or this is the growth rate in technology. So growth rate of real output per capita is equal to the growth rate of total factor productivity divided by 1 minus alpha. Now, if you recall from earlier segments, the alpha can have two interpretations. Alpha is the fraction of income that gets allocated to capital. So that's one explanation. The other explanation of alpha is that it is the elasticity of output with respect to capital. Now what that means is that 1 minus alpha is the total income that is allocated to labor, or it is the elasticity with respect to labor. So in any case, what you need to memorize is that the growth rate of output on a per capita basis is theta over 1 minus alpha. In a stable economy, 1 minus alpha will be stable, and hence the growth rate of output per capita will essentially be determined by the growth rate of technology. What about the overall growth rate of output? This is given by theta over 1 minus alpha, which is simply brought down from here, plus n. N stands for the growth rate of labor. So these are two important relationships that you need to memorize. Now let's take a look at example 10, which will use the relationships that we just talked about. So this example talks about the steady state rate of growth for China, Japan, and Ireland. We are told that earlier examples generated estimates of potential growth for China, Japan, and Ireland. And then we are given some data. So notice that this data aligns with the variables we've just talked about. So for China, the labor cost in total factor cost is 46.5%. Now this is the 1 minus alpha that we've been talking about on the previous slide. The total factor productivity growth rate 2.5%. This is the theta that we just talked about, and the labor force growth of 1.2, this is n. We are then asked to calculate the steady state growth rates from the neoclassical model for China, Japan, and Ireland. We will just do this for China here, and then for practice you can use the same formula to calculate the numbers for Japan and Ireland. The formula that we just learnt is theta over 1 minus alpha plus n. So plugging in the numbers from here for China, theta over 1 minus alpha gives us, so 2.5% is our total factor productivity growth rate, 0.465 is the 1 minus alpha from right here, 1.2 is the labor force growth. So overall what we are predicting is that in steady state the economy will grow at 6.58%. Now again, this is an important relationship. Use this relationship, learn it, and then apply it to Japan and Ireland. Question 2 here says, compare the steady state growth rates for the growth rates in potential GDP estimated in earlier examples. Now, in an earlier example, we came up with a Chinese GDP of 8.6%. So why is this 8.6% different from 6.58? There are two ways of looking at this, and I would also encourage you to read the solution in the curriculum. One simplistic way of looking at this is as follows. The 6.58 is a long-term steady state number. So according to this model, in steady state, in the long run, the Chinese growth rate will be 6.58%. The 8.6% is a current number. So the way you can think of it is China has still not reached a mature state. The economy is still growing. So there are capital investments going on. The relative income of labor is low. So this denominator is a low number. Hence, initially, we will get a relatively high number for this overall expression. In the long run, the incomes will go up, or the fraction of total income allocated to labor goes up. So in the long run, we'll be at 6.58, and that will be steady state. But right now, we are over here. Another item is that we are still in a stage in China where capital deepening is happening. So the return from investing in capital is relatively high, and that is causing relatively high growth. So at our current stage, the overall growth rate is relatively high. But again, in the long run, we will stabilize at this number. So as I mentioned before, make sure you read the explanation in the curriculum. I think this is an important point. And then do the numbers for Japan and Ireland. Okay, now here is another expression that I want you to learn, though I'd say this is not as important as the expressions on the earlier two slides, but still, the derivation of this I feel is complicated and we really don't need to understand it. So it would be a big bonus if you can simply memorize this expression. Let me just explain it to you. The Y over K is the output per unit of capital. S is the savings rate. So this is the percentage or the fraction of income that's saved. Theta, as we've talked about before, is the growth rate of total factor productivity. Alpha, again, we just talked about. This number over here, delta, this is the depreciation rate of capital, and N we've talked about, this is the growth rate of labor. So memorize this expression. We will use it in an example. This is not really used much later on in the end of chapter problems, but still, to be safe, I would say that you should learn this expression. A few points, important points that the curriculum makes. According to the neoclassical model, in steady state, capital deepening has no impact on growth rate. So this is a pretty major statement made by the neoclassical model. Also, in steady state, capital deepening has no impact on marginal product of capital. So know these two facts. In this relatively long section on the neoclassical model, I'd say that the most important part is 5.5.2, which is the implications of the neoclassical model. So in this segment, basically the curriculum takes all the derivations and explanations given earlier and compresses them into four major categories of implications. So I'm actually going to read these out, and you can either just hear me read this or you can read this on your own. So with regards to capital accumulation, the model says that capital accumulation affects the level of output but not the growth rate in the long run. B, regardless of its initial capital to labor ratio or initial level of productivity, a growing economy will move to a point of steady state growth. And point C under capital accumulation is that in steady state, the growth rate of output equals the rate of labor force growth plus the rate of growth in total factor productivity scaled by labor's share of income. So this is the expression that we have been talking about, that the growth rate is given by N plus theta over 1 minus alpha. The second category, capital deepening versus technology. So according to the neoclassical model, the rapid growth that is above the steady state rate of growth occurs when countries first begin to accumulate capital, but growth will slow as the process of accumulation continues. So that would explain why China's growth rate is currently at about 10% or has been at about 10% over the last decade. But according to the neoclassical model, this growth rate will eventually slow down. So point B under capital deepening versus technology, long-term sustainable growth cannot rely solely on capital deepening investment, that is, on increasing the stock of capital relative to labor. If the capital to labor ratio grows too rapidly, that means faster than labor productivity, capital becomes less productive, resulting in slower rather than faster growth. Point C, More generally, increasing the supply of some inputs too rapidly relative to other inputs will lead to diminishing marginal returns and cannot be the basis for sustainable growth. Point D. In the absence of improvements in total factor productivity, the growth of labor productivity and per capita output would eventually slow. And point E. Because of diminishing marginal returns to capital, the only way to sustain growth in potential GDP per capita is through technological change or growth in total factor productivity. This results in an upward shift in the production function. The economy produces more goods and services for any given mix of labor and capital inputs. And then convergence. Given the relative scarcity and hence high marginal productivity of capital and potentially high savings rates in developing countries, the growth rates of developing countries should exceed those of developed countries. And B, as a result, there should be a convergence of per capita incomes between developed and developing countries over time. And now, with respect to the effect of savings on growth, the initial impact of a higher savings rate is to temporarily raise the rate of growth in the economy. In response to the higher saving rate, growth exceeds the steady state growth rate during a transition period. However, the economy returns to the balanced growth path after the transition period. Point B. During the transition period, the economy moves to a higher level of per capita output and productivity. C. Once an economy achieves steady state growth, the growth rate does not depend on the percentage of income saved or invested. Higher savings cannot permanently raise the growth rate of output. And finally, however, countries with higher saving rates will have a higher level of per capita output, a higher capital to labor ratio, and a higher level of labor productivity. So again, I know I have simply read from the curriculum, but this is perhaps the most important segment from all these pages on the neoclassical model. Next, let's take a look at example 11. Beginning in steady state equilibrium, an economy's saving rate suddenly increases from 20% of income to 30% of income, and other key parameters describing the economy are given over here. Using equations 8 and 9, and these are the equations we have seen earlier, calculate the steady state growth rate of per capita income and the steady state output to capital ratio both before and after the change in saving rate. Equation 8 actually deals with the growth rate of per capita income, and this is the theta divided by 1 minus alpha relationship that we spoke about. The theta is 0.02. So this is 0.02 divided by 1 minus alpha, which is 1 minus 0.35, and this is equal to 0.0308 or 3.08%. So this is the predicted steady state growth rate of per capita income. Next, the steady state output to capital ratio. So this is the other expression that I asked you to memorize. So we use this in the examples, but I still think it's relatively low probability that you will get this on the exam. But nevertheless, to be diligent, let us just learn this one. So the output to capital ratio is given by 1 over S, and then we have theta over 1 minus alpha, plus the depreciation rate plus n. When you plug in the numbers, what you should get is 0.4693. this is with a 20% rate. And if the savings rate is 30%, then you should get, actually with the 30% rate you have this number 0.4693, and with the 20% rate, so with 20% rate we have 0.7040. So notice that with the increase in saving rate from 20% to 30%, we actually have Y over K, which is output per capital going down from 0.7040 to 0.4693. So essentially the productivity of capital is going down when we have more saving and more investment. Part 2 says, using the output to capital ratios given in the table along with equation 10 and your answers to question 1 to determine the growth rate of per capita income that will prevail immediately following the change in the saving rate and at each of the indicated times after the change. And then we are supposed to explain the pattern of growth rates. Now this is equation 10, and again, while this is part of your curriculum, I really doubt that you need to memorize this relationship. This expression over here, this thing is psi. This is the K over L that we saw earlier. So I think remembering this is a overkill. What is more important is to observe the following. So our growth rate has gone up from 20% to 30%. Our savings rate has gone up from 20% to 30%. So immediately after this increase, what happens to the output to capital ratio? Notice that this initially is still 0.7040, so this doesn't change immediately. But the growth rate of per capita income, this actually increases to 5.54%. This is because the sudden increase in saving results in rapid capital accumulation. But let's see what happens over time. Over time, the output to capital ratio goes down. So this is over time, the output to capital ratio decreases. As the output to capital ratio decreases, the growth rate of per capita income also decreases, and eventually we are back to the steady state growth rate of 3.08%, which is the number that we saw in the earlier question. So again, here I would strongly encourage you to read the text. Next, part 3, using the output to capital ratios given in the table, calculate the proportional impact of the increased saving rate on the capital to labor ratio and on per capita income over time. With respect to these variables, how will the new steady state compare with the old steady state? On this question, the curriculum uses some complicated expressions that I will not even reproduce over here. All I'll do is just give you a basic intuitive explanation. So when the saving rate goes up, what happens? Initially, so immediately after the increase in saving rate, there is no immediate change on the capital to labor ratio. It takes some time to use the additional saving to buy capital. So initially capital to labor ratio is unchanged, so percentage increase is 0, and therefore the percentage increase in per capita income is also 0. Then 5 years after the increase in saving rate, the capital to labor ratio has gone up to 29.64, and this was calculated using formulas in the curriculum, and I don't think you need to know those formulas. Now, with a higher capital to labor ratio, there is an increase in per capita income of 9.54%. So this is actually also calculated in the curriculum, and I don't think the calculation is important, but you need to have the concept that higher capital to labor ratio means that there is a increase in per capita income. Now, over time, what will happen? Eventually, with the higher saving rate, the capital to labor ratio will stabilize, and here we see that this ratio stabilizes at 86.68%. So we are saying that eventually the proportionate increase in capital to labor ratio is 86.68%, and the corresponding percentage increase in per capita income will eventually be 24.42%. So this is our steady state or stable state. So now let's look at some issues with the neoclassical model. The neoclassical model essentially treats technology impact as a residual. So what that means is this model looks at factors such as labor and capital, and then it looks at growth, and whatever growth cannot be explained by factors such as labor, capital, etc. are then attributed to increases in efficiency or increases in total factor productivity, which is loosely called technology. And if we look at what's happened in developed economies over the last several decades, most of the growth has come because of technology. So it seems a little strange that if most of the change in per capita growth is coming because of technology, then why focus on a model where technology is outside of the model? Another point is that steady state growth rate, and this is according to the neoclassical model. So the model says that steady state growth rate is unrelated to saving and investment rate. So we've seen this in earlier example. And according to this model, the growth rate really depends on the growth of technology and the growth of the labor force. So that's what the model says. But what does empirical evidence suggest? Empirical evidence suggests that there is a positive correlation between saving rate and growth rate. So this to some extent breaks down. And finally, according to the neoclassical model, if capital stock rises faster than the productivity, then return on investment will decline. So this was covered in the segment from the curriculum which I read out. So that's what the model says. But what we have noticed is that for advanced countries, the evidence suggests otherwise. So here again, there are issues. So an extension to the neoclassical model has been suggested, which basically adds inputs like human capital and R&D to the production function. So this is an attempt at making some technology elements part of the model rather than outside the model. And this to some extent addresses the first point over here, but these points still remain unaddressed. And therefore, as happens in economics, if one theory does not quite explain what we observe, then economists come up with other theories. So the other theory here is the endogenous growth theory. Now this theory is actually nothing but a series of models, and these models focus on explaining technological progress rather than treating technological progress as exogenous or outside the model. So as I mentioned earlier, technology, so these models try to put technology and take technology and make it part of the model, and that's where the term endogenous comes from. So the technology is endogenous to the model or part of the model. Now this theory does not assume diminishing marginal returns on capital. It also says that increasing the saving rate permanently increases the rate of growth. An important point made in this model is that R&D related expenditure has high externalities. So what that essentially means is that if a given company or if a given country does R&D research, the benefits of that research don't just impact one company, but that research is copied by several companies in the economy, maybe by several countries across by several companies across different regions, and the impact therefore of R&D related expenditure is huge, and that's where this high externalities come in. So we can't simply treat R&D like regular capital expenditure because the benefit is immense. And according to this model, there is no reason why incomes of developed and developing countries should converge. So according to this theory, convergence will not necessarily happen. So rich countries can keep becoming even richer and further increase the gap between themselves and poorer countries. According to the endogenous growth theory, the percentage change in output per worker, denoted by Y, is equal to the percentage change in capital per labor, denoted by the small case k, and this is equal to S, which is the savings rate, multiplied by C, which is the marginal product of capital, minus the depreciation rate, minus N, which is the growth rate of labor. Now I want you to work on example 12, convergence debate. We have talked briefly about convergence. Now in this segment there are just a few items or a few basic definitions that you need to be aware of. When we talk about absolute convergence in the neoclassical model, what we mean is that developing countries, regardless of their particular characteristics, will eventually catch up with developed countries. So this is a fairly strong statement, and actually evidence does not support the statement, but that's the definition of absolute convergence. Now, absolute convergence implies that per capita growth rates of developed countries and developing countries will eventually converge. So the per capita growth will be the same. But note that this does not mean that the income level will be the same. So just because the growth rate is the same doesn't mean that the income level or the actual income is the same for both developed and developing countries. Now, a more practical concept is that of conditional convergence, which says that convergence is conditional on similar saving rate, population growth rate, and production function. So this makes more sense, that if you have a developed country and a developing country, both have the same saving rate, same population growth rate, and a similar production function, then convergence will take place. Next concept is that of club convergence, which basically implies that you have certain rich countries and certain middle income countries which will converge. So these middle income countries are those whose growth rates will eventually converge with the rich countries. And from an investor perspective, it makes sense to invest in these middle income countries. There are other poorer countries that are caught in a non-convergence trap. So for various reasons, these countries will not, or at least according to this theory, they will not converge with the developed nations. Now, what are the criteria or characteristics of a country that will allow it to converge? And the answer is fairly straightforward. For a poor country to converge, it should develop appropriate legal, political, and economic institutions. Having an open trade policy will also help immensely, and this is covered in the next segment. Section 6, Growth in an Open Economy. This is the last section in this reading. Now, earlier in the reading, section 5.2 to be specific, we talked about the Solow model, which assumes a closed economy, and hence you might have noticed that we used investment and saving interchangeably. The reason is that in a closed economy, the domestic saving is what is invested. So essentially, in the model we talked about, investment is equal to domestic saving. Now, what if we open the economy to trade and capital flows? I will give you the bottom line statement first, and then we will talk about various explanations. The core statement is that open and trade-oriented economies will grow faster than closed economies. And essentially, this section talks about why this is the case. So let's look at the first high-level explanation for why open and trade-oriented economies grow faster. First point is that open economies can borrow and lend in the global markets. So if the investment opportunity is relatively high, but domestic savings are low, money can be borrowed from international markets. So essentially then investment is not constrained by domestic savings. The second point is that in an open economy, resources will automatically be used more efficiently. Why? Because in an open economy, resources will be shifted to industries where a country has comparative advantage. So if a country has a comparative advantage in agricultural products, then more resources will be shifted into that industry, and in other words, resources are then being used more efficiently. Next point, in an open economy, companies have access to much larger markets, larger global markets for their products. This means that if companies are producing on a much larger scale, then there will be more economies of scale. So the per product unit costs will come down, and that obviously is more efficient. Companies and countries are able to import technology more efficiently. So rather than having to do all research and development on their own and having a long period to innovate, companies can adopt technologies that have been developed in other countries and hence grow at a relatively faster rate. Finally, greater global competition will force companies to become more efficient, which again encourages growth. As we saw in section 5, the neoclassical model predicts that economies in developed and developing countries will converge. So what's the impact on convergence of having open economies? And what the model tells us is that if we have an open economy, it will converge faster, because in an open economy, the capital to labor ratio will converge faster. In other words, when we have an open economy, capital will flow more easily towards countries where the marginal product of capital is relatively high, and hence the conversion is faster. Now let's look at what happens from the perspective of a developing nation. So developing nations have higher marginal product of capital. I mentioned that briefly, but just as a quick refresher, if this is the production function, this is our output per labor, this is our capital per labor. Developing nations are somewhere over here, which means that the output per unit of capital is higher, so higher marginal product of capital. This means that the returns on investment will be higher. So clearly investments made in developing countries, which are over here, will produce a greater return relative to investments made in developed countries, which might be somewhere here. So returns are higher, that means more money would flow into developing nations. Since more money is flowing in, more investment is happening, physical stock is going up. Physical stock going up per unit of labor means that economy is more productive on a per labor basis. Greater productivity means that incomes go up in developing countries and converge or are in the process of converging with developed nations. Basic economics tells us that capital inflows have to be matched by offsetting trade flows. So high capital inflow into a developing nation means that imports must be going up. If imports are going up, that means that we have a trade deficit. Next point, growth rates in developing nations will be high, but this is a temporary phenomenon. So we will eventually reach steady state, and in steady state the growth rate will be stable and like the growth rate and comparable to the growth rate in developed nations. And how do we come up with this steady state growth rate? This is the formula that we saw in section 5. Point number 6, eventually investment rate and trade deficit will decline. So the point is that as a developed nation moves up on this production function and is at a point where we are now at relatively low marginal product of capital, then obviously the investment rate will go down. As investment rates go down, the trade deficit also declines or improves because imports will go down. And if we get to a level where the investment falls below domestic saving, then the country will shift towards a trade surplus and even become an exporter of capital. And finally, as a general point, in the Solow model, so this is the neoclassical model, no permanent increase in growth rate of economy. So there is no permanent increase in the growth rate of economy. Developed and developing countries will eventually grow at the steady state growth rate. So that was the neoclassical model. What does the endogenous growth model say? So this model predicts that an open trade policy will permanently raise level of economic growth. Why? Because of three major reasons. Number one, global competition forces less efficient companies to exit and more efficient companies to innovate and become even more efficient. So this will spur growth rates. Second, economies of scale by selling to a larger market. So because of a large global market, the economies of scale come into play, which again makes countries and obviously the companies in those countries even more efficient. So that will increase growth rate. And finally, the knowledge spillover effect. So this is externalities at a global level. Less advanced countries can catch up because the technologies that are developed in the more advanced countries can easily be adopted by these less advanced countries, and that again will spur growth. So at a high level, you need to understand these three reasons and recognize the core point that with the endogenous growth model, the growth rate can be permanently higher. Now, even though there is immense evidence that open trade policies allowing free movement of capital is good for economic development, yet several countries, and two prime examples that are given in the curriculum are Venezuela and Argentina. So they have over the last few decades followed what's called inward oriented policies. So according to these policies, what countries do is to encourage local industry, they put restrictions on flow of goods and services, restrictions on flow of capital, and again with the objective of improving domestic industries. But there is sufficient evidence that tells us that this policy results in subpar growth rates. On the other hand, the curriculum gives examples of India and China, which once they opened their trade policies have experienced immense growth rates, much higher than the growth rates in developed nations and higher than growth rates in developing countries with inward-oriented policies. So what is the bottom line? And here we repeat the point that we made at the start of this segment, which is that open and trade-oriented economies will grow faster than closed economies. So that's a quick overview of section 6. What I now want you to do is read examples 13 and 14. Example 13 will tell you about the situation of India and China, and example 14 talks about why some countries converge and some do not. These are short examples and just interesting to read. Example 15 is more elaborate. You need to work through this, and in the process you will also revise a fair amount of material from earlier sections. So that's it. We are done with this reading. I want you to take a quick look at all these learning objectives. We have covered all these in the course of our lectures. And after having done this, I want you to do the practice problems at the end of this reading. So there are 21 questions. Make sure you do these very carefully. That is it.